Alright, in this video we're going to review a half-life problem. So years ago, many years ago, they used to use radioactive radium-226 and put it in paint to make the paint glow in the dark. That's what this problem is about. Suppose there is 200 grams of radioactive radium-226 from glow-in-the-dark watches in the city dump. If the half-life of radium is 1600 years, determine how long it will take to reduce the sample to less than 1 gram. So I like to make myself a little chart when I do these problems with these three headings. The number of half-lives, if I actually wanted to count the half-lives, the time for the half-life, and then the amount of my sample. So I have to have my what I call starting conditions. So my starting conditions is at time 0. I have 200 grams. And no half-lives have passed yet. So that's a mistake sometimes people make, is you have to have the starting conditions there. And then someone has to tell you the half-life of the isotope, or you have to look it up. And our half-life is 1600 years. So because of that, I'm going to make this in years. So after one half-life, which would be 1600 years, half of my sample would be gone. So I'd be down to 100. After another half-life, which would be 3200 years, I would have half of my sample. So the question is, how long until I get less than 1 gram? So let's just do this column for a second. So I'm going to end up with 25, then half of it would be 12.5, then 6.25. I think I need my calculator to help me now. So we'll take 6.25 to 6.25 and we'll divide by, I don't know if you can see that, divided by 2 is 3.125, so 3.125. We'll divide that by 2, 1.5625. We'll divide that by 2. And now we are under 1 gram, which is what we are looking at. So 0.78125. So the question is, how long is that? So I can see that it took me this many half-lives, 6, 7, someplace between the 7th and the 8th half-life. And I just have to keep adding 1600 as I go down. So I'm going to take 1600 times 7, 1600 times 7. And that would be 6,400. Then I'm going to take 1600 times 8, 1600 times 8, and that would be 1,800 years. So I can see that someplace between the 7 and 8 is when I get under 1 gram, and that's as close as you need to come. So you could report this answer that after 12,800 years, I would be at 0.78 grams, which is under the 1 gram.